Let's welcome Pankaj Sethi, Business Segment Manager, Automation at Wago. At present, Pankaj Sethi is the Manager of Business Segment of Automation at Wago India, one of the global leading interconnection technology firm with sizable presence in energy automation sector. He has over 18 years of experience in energy automation and has been instrumental in development of automation systems in several private and state power utilities across India. He has represented Wago India as an opinion leader in various prestigious energy sector publications. In his current capacity, Mr. Sethi is responsible for strengthening Wago automation business footprint across multiple sectors, including energy across countries in the India subcontinent. Previously, Mr. Sethi has been associated with MNCs like Siemens Limited and he has pursued sales and marketing management specialization from the Indian Institute Management, Calcutta, and Bachelor of Engineering degree from Dayanand University. Mr. Sethi will present talk on digital evolution in automation. So let's welcome Mr. Sethi.
To talk about the digital evolution in energy systems. I would like to cover today like how the digitalization has evolved in the power sector. Is it in the timeline? Okay, and what are the digitalization initiatives that are ongoing into the market now? And we'll talk about a little bit about digital and virtual substation concepts, and then the cloud computing and distribution automation. So that would be the agenda. I'll try to cover up within the given timeline. Okay, so see, the digitalization is a very, very vast topic if we talk about the power sector, because the power sector value chain is a big value chain. It starts from the generation to the consumer. A lot of stuff is there inside control centers, right? And every aspect of this value chain in energy sector is going through some or other sort of digitalization, right? So I have tried to list it here, like in substation, we are seeing the digitalization in substation automation. And then we see distribution automation being now integrated to more cloud and IoT-based solutions. The billing systems are getting towards the advanced metering infrastructure. The control centers are getting advanced with ADMS, EMS system, and predictions. Even the power trading, online power trading is now happening through blockchain technology, and the renewable plant integration with the grids. So the digitalization happening through virtual power plant technology. And when we have distributed resources of energy, again, these need to be integrated, and everything is starting to communicate and integrate with the system. So a lot of digitalization initiatives are ongoing. So talking about everything is not possible. So what I will do, I'll restrict my discussion primarily towards the distribution segment. So I'll try to cover up the substation and probably the distribution network automation in my slides. Okay, so if you see the digital evolution timeline, so this is basically that evolution has been an effect of some cause, okay? And the cause is nothing but some sort of innovations that happened over the period of time. Like in 1920s, we had the innovation related to the electromagnet. So we saw electromechanical relays were introduced into the power network. And then by 1960s, semiconductors were invented. Then we saw the solid state relays coming in the power sector. Okay, by the time the semiconductor was there, then the serial communication also got invented. So then we saw that early 1970s, we saw that we had remote terminal unit, probably the first automation system that was implementing the substation to send the substation data in an automatic way to the control centers. By 1990s, this microprocessor technology got much more evolved and much more matured. So then we saw the same being implemented into an energy network by means of numerical relays, and we continue to use those technology still today. By 2000, so the communication became more sophisticated. We have the Ethernet, we have the IC104 and 620 protocol coming in for the power network. And we see that substation automation system becoming more popular. And 99% of the substations that we see today in India, from transmission or distribution, have some sort of substation automation system or getting some sort of substation automation system in coming times, which is based on IEC 61850 protocol. But after that, so now I call it a conventional system. So that was not the case when 5-6 years back. We're not saying that substation automation system to be a conventional system, but now we call that as a conventional system because from 2015 onward, we see is modern and futuristic automation coming in, which is more dependent and more data-driven and data processing oriented. So by 2015, we saw changes happening into that the IEC 1650 protocol was much further evolved to get 9-2, which is process bus, with Ethernet technology getting more advanced with PRP, HSR, and PTP protocols coming in, and the cloud technology becoming more prevalent with IoT, AI, and machine learning coming in. So we now see the distribution automation system also getting towards the cloud technology. And what is the future? The future would be that line that you see here, which separates the protection technology and control and monitoring, will be gradually getting diminished. And what we will see that we'll have virtual protection and automation system going forward with coming edge computing technology and container technologies coming in. And there the alliances, global alliances like VPAC Alliance and E4 Alliance are working, and Wago is also working there to make that futuristic protection and automation system. So coming to my next topic, so I'll not be talking this in too detail because the topic would be the next, but here just to show that how the conventional substation automation system, which is currently being used today, and how it will be different going forward. So what we see here is a standard electrical yard is there, and the control room with numerical relays are there with IC 60 station bus. The relays are there for protection of the entire network, and they take data from instrumentation transformer in the yard through analog lines, which are voltage and current signal wired through copper, and the breakers are also connected to the big IDs through copper cable for inputs and outputs. But this is in the digital substation. When we come, we see that the control room side remain more or less same with IC 620 station bus, and the electrical side remaining more or less similar. But what changes here is the digitalization of the way that analog informations are being taken. Now with coming in of process bus technology, we see VMS is like voltage merging sensors, and Siemens is like current merging sensors. They acquire data directly from in the yard from the instrumentation transformers, convert that information to sampled values based on the standard of process bus, and over the network using PRP, they send to the data to the IEDs. Okay, and the IED also for the breaker management, IED also talk through those messages to the breaker management unit. And Wago is very actively working, and these are the products which will be there in the market from Wago very soon on having the voltage merging sensor and current merging sensor and the BMUs, which will be helping the industry to adopt digital substation at very much, in a very competitive manner. Okay, so this technology has helped for elimination of copper and the cost related to copper and the maintenance issues. But still, some issues continue to be there, which are that this still is hardware dependent. Okay, so you still need to have IEDs in the control room to take the decisions there for production of the electrical network. Okay, again, this remains very vendor specific because you are buying IED from one particular vendor, so your entire engineering process has to be aligned with that particular vendor, and the equipment cost becomes high. Though you eliminate the copper, but you have to add more components, like you have to add merging units, and you have to add the PRP network between the yard and the control room. So your equipment cost remains high. So what next? Here comes the futuristic approach, which is called virtual protection and automation system. So here the baseline technology would continue to remain same, which would be the process bus. Since the data is now already available in the digital format from the yard, Okay, so probably we might not need IEDs in the future, right? So what we can have is the edge computing technology, where we put the redundant servers onto in the control room, and this onto that we run virtual environment of merging the analog values or sampled values that we are getting onto that. We build up virtual applications of IEDs and containerize those applications through container technology and load it onto the virtual environment. And similarly, we can have virtual applications for power quality and virtual applications for RTUs and gateways. So what does it mean? That once we have the data available in the digital format, using that computing technology, we can do all the functions what IEDs are doing as of now. So the manufacturers they don't need to build IDs and hardware. So ID can be just a software. You take that software, install into your virtual environment on your edge computing, and it does what it's supposed to do. And the benefits that everything becomes software defined, virtualized and containerized, it becomes hardware agnostic. So no dependency on specific hardware or a specific manufacturer, because the standardization, the people are working for standardization of these environments. So people work in making any standard hardware will be able to use any ID. So multi-vendor approach can be there. So algorithm of one ID of one manufacturer is good, you can have that ID. And if algorithm of another manufacturer for other function is good, you can have that ID, virtual ID from that vendor. And the things become more open source and standardized. So this would be the future of protection and automation technology, and Wago is working here with the people in the industry and with our products, where we can bring and make this change for the power networks. Okay, so moving on to my next topic, which is the cloud computing in distribution automation. So what you see on my screen is on the left side, you see a standard underground cable distribution network using RMUs with FRTUs, which are talking to control centers. And on the right side, you see an overhead distribution network with FPIs and probably a DCU, again talking to the control center on wireless, a very standard thing which is already there. But the FPIs are the devices like which are the sensors which sense the fault into the line, gives the data to the DC or FRTU, and then this information is sent to the control center. So very standard. But now coming in with the FRTUs, which are IoT enabled. Okay, like all our products, Wago products are IoT enabled. The same way they can communicate parallelly to the control center and also to the cloud. That makes the change in the entire scenario. So here what happens, so FRTUs getting data from the sensors when they're enabled with IoT applications on 4G network or 5G network using standard MQTT protocol, they can send data to the cloud. And onto the cloud, the applications like this, the communication happens between the cloud and the cloud, between the FRTUs and the cloud application through MQTT, and that applications are accessible to the users through their mobile networks, mobile devices like mobile phone, tab, or laptop through internet. Now, how it helps the users? So anyway, the data was going to the control center, but the control center is again a centralized system where it is based at one location, and the people responsible control centers are not the guys who are responsible for the maintenance of the grid network, right? So this mobile app can be with the guy in distribution company, maybe a junior engineer or somebody who has access to the cloud application over his mobile phone. So whenever a fault is detected and communicated to the cloud, the notification goes to that junior engineer on his mobile phone with the fault information that some fault has happened. And all the assets connected to the cloud are geo-coordinated, tagged. That means the user will get the precise geographic location of where the fault has happened. So the time that he has to spend in patrolling the circuit to see and identify where the fault has happened is almost eliminated. And he can just go directly to the location of the fault and do the restoration activities instead of putting time in finding the faults. So how it helps is it improves, it makes the grid more reliable, that the restoration time is reduced very significantly. So it helps improving the SADI for the distribution companies. And since all the assets are geotagged, so it's like a Google map or sort of something on which he sees the guy responsible for his zone, sees the entire network with all the asset, transformer, RMUs, the overhead network, and he sees what is happening into his territory, right? So he sees the healthiness of each component, he sees the status, he sees the metering values of each component, okay? So it helps him to see the overall picture of his network on his mobile phone with the geotag information. And since cloud technologies are using and taking advantage of AI and ML, so that means the information which is being gathered by the cloud can also be further processed for doing more analysis and predictions, right? So the reports can be generated based on the history of the faults that has happened. And it also helps to define over the period of time the fault-prone zones predictions into the network. So if there are such faults are there which are continuously going through the fault, maybe transient faults or the permanent faults. So these information helps to make those prediction, and it gives the information visually also and in the report also to the user where the fault prone zones are lying. So the corrective action, if required, can be taken by the concerned person. So that was my session for the day, and some notes from where I have taken the information.
Thank you, Mr. Sethi, for sharing your views on digital evolution in automation.